Good evening, this is Kavipriya, Assistant Professor, EC Department. I am going to discuss about the topic pulse width modulation, which is a type of pulse communication. First, what is this pulse width modulation? A modulation technique where width of the pulse of a pulsed carrier wave is changed accordingly to the amplitude of modulating signal is known as a pulse width modulation. We call it as a PWM. It is also known as a pulse duration modulation PDM. In pulse duration modulation, the amplitude of the pulse is kept constant and only the variation in the width is noticed, as the information component is present in the width of the pulses. Thus, during a signal transmission, the signal undergoes a pulse width modulation. Due to constant amplitude property, it gets less affected by the noise. During transmission, there is a chance for the noise to get introduced. So, there is a change in the variation in the amplitude. But that is totally easily removable at the receiver side by making use of the limiter circuit. First, we can see what is the process that is involved in the generation of PWM signal, pulse width modulated signal. The message signal and the carrier waveform is fed to the modulator, which generates the PAM, pulse amplitude modulated signal. This pulse amplitude modulated signal is fed to the non-inverting terminal of the comparator. The RAM signal that is being generated by the sawtooth generator is fed to the inverting terminal of the comparator. These two signals are added and compared with the reference voltage of the comparator circuit. The level of the comparator is adjusted to have the intersection of reference with the slope of the waveform. The PWM pulse begins with the leading edge of the RAM signal and width of the pulse is determined by the comparator circuit. So first image shows the waveform of a sinusoidal modulating signal. Second one is the pulsed carrier. So after modulation, a PAM signal is generated, which is shown in the figure C. This PAM signal, when added with the RAM signal, which is shown in the figure D, is compared with the reference voltage of the comparator, which is shown in the figure E. Lastly, the figure F shows the pulse width modulated signal. So, the width of the pulses is directly dependent on the portion of the waveform that lies above the comparator level. So, the pulse width modulated signal is generated, which is shown in the figure F. And next one is a deduction of the pulse width modulated signal. So the diagram shows the pulse width modulation detector circuit that provides the original message from the modulated one. Some noise will get added to this pulse width modulated signal. So first we have to remove the noise introduced in the transmitted signal. So the incoming signal is fed to the pulse generator. This generates the pulse width modulated signal. This generated PWM pulse is then given to the reference pulse generator that generates the pulses of constant amplitude along with the constant width. The generated pulse is also given to the RAM generator that generates a RAM signal of a constant slope, whose duration is similar to that of the pulse duration. The constant amplitude pulses are then provided to summation unit in order to get the added with the RAM signal. The added output is then fed to the clipper. This clips off the signal up to its threshold value, thereby generating a PM signal at its output. This PAM signal is now given to the low pass filter in order to generate the original message signal from the modulated one. And what are all the advantages of this pulse width modulation signal? The first advantage is that it is more immune to the channel induced noise than the PAM. As noise adds to the amplitude, thus a reconstruction of the PWM signal from the distorted PWM signal is somewhat easier. And the transmission and reception there is no need for synchronization of the transmission and the reception. Drawback is that due to changing with the width of the pulses, variation in the transmission power is also noticed. Second one, bandwidth requirement in case of this pulse width modulation is somewhat larger than the pulse amplitude modulation. Application: it is used in telecommunication, it is used in brightness controlling of light, and also used in speed controlling of fans. So that's all about the pulse amplitude modulation. What is pulse amplitude modulation, and what is the modulation circuit, and what is the demodulation circuit, and what are all the advantages of this pulse amplitude modulation, and what are all the drawbacks of this pulse amplitude modulation, and finally we have seen what is the application of this pulse amplitude modulation. Thank you.